We are working on the Sports Heroes project from the YByte Python curriculum available at www.ybyte.in. Previously, we created a winner set, which was, let's say, the set of all the unique winners of Wimbledon. And we went on to do some further analysis, which we have captured in this file analysis.dat, which tells us, who are the people who have won Wimbledon, how many times they have won it, which country do they belong to, and which are the years they have won it. Now, we are going to move forward with this analysis in this video. In fact, a very interesting question comes up, which is that, look, we have all, let's say, these winners of Wimbledon. Clearly, some of these are, have won it more than once. For example, Jimmy Connors won it twice, McEnroe won it thrice, Djokovic, recent times, has won it 7 times, and so on. So, so basically, there's a subset of this set which are those people who have won Wimbledon more than once. Now, in this video, we will create the subset and look at some of its properties. So what I am after is, let's say, a set called MTO winners set. Now, by MTO, I mean more than once. I create this as an empty set. We will first copy all the values of the winner set into this set, and thereafter we'll remove those people who have won Wimbledon only once. So let's do it in 2 steps. So first I create a for loop. Let's say I say for player in, let's say, winners, say set. Now this has to be again winner set, because if you want only the unique values to be coming out, I just go and say, look, please add, so MTO winner set dot add, let's say the player. So this is going to make the MTO winner set to start with exactly same as the winner set. However, I now want to remove those players who have won the Wimbledon only once. And clearly, I have this information available from this winners info list, which, remember, is a list of dictionaries. For every player, I have all the information, which I've also displayed in the analysis.dat. So what I'm going to do is I'm going to again run a for loop here. I guess say for, let's say, player, say player in, say, winners set. Again, on the same set, I run the for loop. I just have to find out those players that I have to remove. Basically, I will just go through every item on this list, winners info list. Basically, I'll go through every dictionary in this list, winners info list, and I will remove those where the players, let's say, this particular key times 1 results in, let's say, 1. um, Quite similar to what we are doing earlier. So I just do it using list comprehension. So I just say, well, selected is equal to, let's say, chosen for chosen in. Now notice this is winners info list. So I'm choosing in this, let's say, filtered list that I have, and I choose this based on if, let's say, chosen name is equal to player. So in fact, I'm doing the operation almost similar to what I was doing over here previously when we went from tournament data to figure out, well, where all does the player name appear. In fact, the same thing we are doing here, but on a different list of dictionaries, which is in this case winners info list. So I just go and choose that player. Now obviously selected is a list. However, selected has just one item, which itself is a dictionary. We've spoken about this before. I want to find out, I want to find out if I want to retain this person in the MTO winner set or not. I just do this by saying that, look, if selected, say, say selected, say 0, say, times, say times 1 is equal to 1. So basically what I'm doing is, look, selected is a list. I'm looking at its first item. Actually, the list has always got one item only, but I look at it, that particular item, which is dictionary. I go and look at the value for the key times 1. If that happens to be 1, it means that the player has won the tournament only once, and hence I will remove this player from, let's say, dot, let's say, remove, say, player. So we are also seeing in this process the usage of add and remove to a set. First we added all the values to the set, and now we are removing some of those which have won only once. Now we can run this code to get a better feel for what's going on, and then we'll have some more discussion on this. So when I run this code, notice my winners set is, let's say, this set. I think we know that the length of this is 22. So if I do winners set is 22. Now I am also going to look at the MTO winner set. That is, you can clearly see it's smaller. If I were to look at the length of the MTO winner sets, now if we were to look at the length of the MTO winner set, that is 13, which means that out of these 22 people, who are obviously remarkable individuals who have gone ahead and won a Wimbledon tournament, out of these there are these 13 people, 13 exceptionally gifted brilliant players who have won this tournament more than once. Now, what we have done here is created a subset. MTO winner set is called a subset of winner set. And how do I see that? Well, if I were to look at MTO, say, winners set is less than, let's say, winners set, that returns me a true, because MTO winner set is a subset of the winner set. What it means is that every item that's present on the MTO winner set is present in the winner set, and winner set has possibly got other things as well. We can just see for as an example, let's say 1 2 3, which is say 1 2 3, which is a set, is a subset of, let's say, 1 2, let's say 3 4 5. This statement results me true. Notice here, this less than sign basically is like telling is a subset or not. On the other hand, if I were to do the same thing, let's say 1 2, let's say 7, this is going to be false, because notice there is a value here 7 which is not present in this bigger set. In fact, there is a very interesting representation of this entire let's say process, this entire, let's say, notion of subset and so on. Basically, this is called a Venn diagram representation. Here, for example, we have a huge set of, let's say, all tennis players. Now this could include even players who, let's say, do not even have, maybe never reached the finals of Wimbledon, but they are very, very good tennis players anyway. So there's a huge set of people, out of which there is this remarkable set of people who have won, Wimbledon at least once. So that's all the Wimbledon winners. But within that, we have further got a set which is called, which is our MTO winner set. These are people who have won Wimbledon more than once. Now, an important point to understand here is that the relative sizes are not important. So we're not trying to say that, look, like, let's say half of people have won. That's not the indication. The whole point is that, look, this, or let's say the yellow circle is fully contained inside this yellow rectangle, which is logical because all Wimbledon players are fundamentally tennis players. And this, let's say, inner red circle is again fully contained in the outer yellow circle, which is again logical because all Wimbledon players who have won the Wimbledon more than once clearly I have won the Wimbledon, which means they are a part of this set as well. So, which is why the MTO winner set is a subset of the bigger set. Very, very interesting concepts, which you will, encounter a lot in mathematics as you move forward. Now, before I wrap this up, I want to leave you with a food for thought. You realize that, when we created the MTO winner set, we did something which looked a little bit roundabout. We first added all the items of the winner set to the MTO winner set, and then we went and removed the items. So one question that might come to your mind is that, well, why couldn't I just do a simple statement, MTO winner set is equal to winner set? I urge you to try this in your code, and something pretty interesting will start to happen. Now this is related to what is called shallow copying in Python. If I were to do the statement as I've shown here, in fact it will create what is called a shallow copy. Now we will look at this whole concept of shallow and deep copying in a later part of the course, but nonetheless very happy to discuss in case you are have any thoughts on this. Do try this, and like I said, I'm very, very happy to discuss this with you. Once again, we find that applying concepts to an activity makes them much, much more interesting, and our understanding of them becomes much better as well. That is how we learn Python at Ybyte. Look at our website for many such lessons. Take care. Thank you so much. Bye bye.